Hello students, we are starting for today, but before we start solving problems, I have to announce you something. Like maybe you've seen this in our maths classroom here in Maths 2. There was this paper for American mathematics competitions. I just want to inform you that the registration deadline is January 29th of January, so you don't have much time if you're interested on participating on these competitions. You have the link here, harmonyeducation.net. If you're interested on this competition, you can contact us later. All right, let's start with the first problem for today. Let A, B, C, D be a quadrilateral. Let E and F be the midpoints of A, B, and C, D respectively. So prove that the midpoints of the sides AF, BF, CF, DF form a parallelogram. You will have 3-4 minutes to copy it and to give a try, then we will start revealing the solution. All right, I have a sketch here. You need to know that it's difficult to draw properly in scale this problem because the parallelogram will be very small. I mean, it's not visible correctly. So and here the sides are not, and for example, it's not exactly in the middle, but I moved them a little bit so that it will look like a parallelogram. All right, so we have a quadrilateral A, B, C, and D. E is the midpoint of AB. F is the midpoint of CD, as it's given here. Now we need to prove that the midpoint AF, which is K, then we denote it with K. This one with L, which is the midpoint of EC. Then the midpoint of FB is M, and the midpoint of DE is N. So let K, L, M, N be the midpoints of these four lines respectively. We will prove that K, M, and L, N are bisecting each other. Why do we need this one? If you have a parallelogram, we know the property that if you have a parallelogram, diagonals bisect each other. So if we prove that the diagonals bisect, it means that the shape is a parallelogram. If you already solved the problem, write that on comments, please. Here you have the text. It's not given that they are parallel. It just says that F is the midpoint of CD and E is the midpoint of AB. In some cases they may be parallel, but in general they are not. All right, let us see something else that may help us. So as you see the triangle, from the triangle CDE, the point M and the point N are the midpoints. The point M M, N, and F are the midpoints of the sides of. All right, Philip. That's an option also. All right. Let's continue here. Philip, you can just play back the video and you can copy the text. All right. From the triangle CDE, we have that the points from the triangle CDE, the points L, N, and F are midpoints of the sides DE, EC, and CD. So what's helping that? It helps that the quadrilateral E, L, F, N is a parallelogram. How do we know that? I'll draw here another parallelogram. So it's like this. If you have a triangle, and these are the midpoints, then this shape is a parallelogram, because this side is parallel to this side, and this side is parallel to this side. So we apply that property here, and we see that the quadrilateral ELFN is a parallelogram. All right, then let's see here, if ELFN is a parallelogram, then it means that the diagonals of that quadrilateral, which are LN and EF, bisect each other. Now the idea, if we do the same thing, but now for the triangle ABF, which is this triangle here, ABF, if we do the same one, but for ABF, now the midpoints are K, E, and M. It means the quadrilateral EKFM is a parallelogram. So what does that mean? That means that the diagonal KM bisects EF. So KM bisects EF. And the last part, if LN and KM bisects each other, and KM and FE bisects each other, that means that LN and KM bisects each other. I can draw it here. So let's draw EF. And KM, in the beginning it was LN, so it's this one. So this side is equal to this side, and this side is equal to this side. Well, the same side EF bisects KM, well, it must pass through this point because it bisects. So it must pass here. It means that this side is equal to this side. And we showed that these two lines, ANL and KM, bisects each other. That means that KLMN is a parallelogram. Is that clear? If you have any question, write them in comments, please. All right, we will continue with the other problem, the 17th one. So today is the second one. These two problems were meant for yesterday, but we didn't have enough time. I think you say top triangle, which has a one angle bigger than 90 degrees. This notation BPQC, this notation we used, I think, during the first day or second day. It says that these points are in this alignment. So you have B, then P, then Q, then C. It's not B, Q, P, C. So it's just the arrangement of the points. And Philippe, obtuse is this one. Acute, obtuse. It has an angle bigger than 90 degrees, obviously less than 180. Yes, 100. This year it's 100. Yes, trisection means divides into 3 equal parts. Not segments, because it's saying about the angle, so it trisects the angle, not the segments. right, let's try to solve this problem now. First, we will sketch it. It said we need to have an obtuse triangle, so ABC, like this. These three angles are equal, so these are all equal because it said that AP and AQ trisects the angle there. So let's us add here another line, which will be the angle bisector of the angle BAC. So let R be the intersection of angle bisector of BAC and BC. So the point here, let us draw it here. Once more, as you see, I'm not constructing it, I'm just guessing where it can be somewhere. So this is point R. Here we have that AP over AQ, AP over AQ is PR over RQ. How do we know that this holds? Well, I can show you something else here. Maybe you know. If you have a triangle here, this side A, this B, and this will be angle bisector. This one, let's say it's M, and this one N. Then A over M is B over N. We just applied this property here. Great. So here we have angle bisector. If it's bisecting the triangle ABC, it means that AP, which is still angle bisector of this one, those two small triangles, angles here are equal also. It means that AP over AQ is PR over RQ. Is that clear? All right, we will continue. We have here a question. Why this PR is 35x over x plus 1? Which one showed that PR is 35x over x plus 1? Because we denoted x, this ratio, AP over AQ. None of you showed that they are equal? All right, I'll show you the workout here. Because PR over RQ is equal to x, this will be PQ minus PR. Wait for me 1 minute, I'll come back. All right, let's continue. Where we left, PR over, this is PQ minus PR, because PQ minus PR, here PQ minus PR is RQ, which is the equation here. This should be X. PQ, I just took the inverse here, so PR is given, it's 35 from the problem. This one is 35, PQ minus PR is 35. I just did have some expressions here, and after calculations you end up that PR is 35x over x plus 1. After you find PR, you can find RQ easily. How? Just substitute here on this equation here, and you find that this one RQ is 35 over x plus 1. Is that clear? All right, let's continue. I have another paper full of calculations, as you see. All right. Now, to solve the problem, we need to take some other points, like the point B prime, which will be the symmetric point of point B. This WORO means with respect of. Let B prime be the symmetric point of B with respect of AR, and AR was the angle bisector. All right, and the other point, P prime, will be the symmetric point with respect of R of point P. Of point P with respect of AR. So I'm drawing it once more here. Let's take the symmetric point of B. It will be exactly here. How do we know it will be here? And P prime will be here. All right, let's check it here once more. It's easy to show that BP is equal to B prime P prime, and PR is equal to P prime R. Now we apply the Menelaus theorem, Menelaus, oh I forgot an E here, Menelaus theorem for the triangle CRB prime and the line P prime Q. We studied about Menelaus theorem yesterday. I think all of you remember that one, but I will do a quick review about that one. Let's say is this A, B, C, and we continue this line, we extend it. We will have 3 points, let's say D, E, and F. Then this proportion holds AD over DB times B F BF over FC times CE over EA is 1. This was the Menelaus theorem, but now we will apply it for these two triangles. For the triangle CRB prime, so it's this triangle CRB prime, and for the line QP, we apply the Menelaus theorem for this triangle here. All right, let's see it now here. We end up with this proportion. 1 is equal CQ over QR times R pi prime over pi PB prime times B prime A over AC. And here we just substituted the last from this row here. We found that BP is B prime P prime, so we just substitute it here and end up with this equation. All right. Is that clear? Any question till here? Do you have any questions? All right, let's continue. Now what's left? Just calculations. We will substitute on this equation here. 1 is equal CQ, which is 100 over QR, which is 35 over x plus 1, times PR, which is 35x over x plus 1, PB, which is 21, and AB over AC, we said it will be Y on the beginning. Did we mention that one? Sorry, we haven't mentioned that one. So just this one, AB over AC, we'll just denote that by Y. All right, if you do some calculations, you will end up that 1 is equal to 100x y over 21. It means that 100x y is 21. Great. Now, from the theorem of angle bisector, which we mentioned on the beginning, AB over AC will be BR over RC. And we know BR will be 21 plus 35x over x plus 1, and RC will be 100 over 35 over x plus 1. After some calculations, we will have 56x plus 21 over 100x plus 135, which is this fraction. And just to remind once more, we are looking for the ratio of AB over AC, which means we are looking for Y. We need to solve this equation for Y. There are a lot of ways now to solve this one. It's just an algebraic expression. So I skipped calculations. You will have 135 I'll give you 3 minutes to finish the calculations and show me the answer. All right, let's do the last substitution. So here we have 135y equals 56x, and here we have 100x times y, it's 21. So x is equal 21 over 100y. Let's substitute here. 135y is 56 times 21 over 100y. It means that y squared is 56 times 21 over 100 times 135. From here we have that y is square root of this expression, 56 times 21 over 100 minus 100 times, 135, which is a number. We need to calculate it. All right, we can leave it from here. Is that clear? All right, let's continue with the other problem. You will have 5 minutes to copy and to try to solve this problem. All right, ABCD is a square. Let ABCD be a square. M is any point on the side CT such that ME is perpendicular to MA. ME is equal to MA. So we have this sketch. ABCD is square. This one is perpendicular also. MA and ME are equal and they are perpendicular. All right. So if these two sides are equal, it means that this angle here is, we can write it, it's 45 degrees. Let's show something from the solution. We have that. Let us first construct or draw the diagonal BD and AC. What do we see here? Let's denote this angle here. Let's denote this angle with, as I've denoted here, X. And let's denote this angle also with X because they are equal. Why those two angles are equal? Any comments? All right. Here we have 90-degree angle, so if this is x minus 90, so this angle here is x. Let's do the same here. This angle DAC is 45 degrees. DAC is 45, so this angle is 45 minus x, is it? But the angle MAE is also 45 degrees. How do we know? Because it's given that ME is equal to MA. If we have an isosceles right angle triangle, it means that the angles on top of the bases are 45 degrees. So this angle MAE is 45 degrees. So if this is 45 degrees, it means that this angle here is x also. All right, now what do we see? First, let us denote this point here with K. And let us connect the points A, D, M, K. What do we see here? I'll try to make it blue. So this one is perpendicular here. I will leave it to you to show it that it's perpendicular. You can prove it. it's not difficult. So if this angle AKM is 90 degrees, right angle, and ADM is 90 degrees, also it says that the quadrilateral ADMK is a cyclic. What does that mean to be cyclic? There exists a circle that passes through all these points. Here is how I showed that that triangle is 90 degrees here, because DAK is equal to CMK. These two angles are equal, so that we can show it's cyclic. It means that it's 90 degrees. All right. Also, the other quadrilateral MKEC is a cyclic, and which is that triangle M K E just 1 second, MKNC here with this notation that I've used. MKNC is a cyclic. Yes, MKNC is a cyclic, so CMN is equal to CKE, which is 2KAC, which is 2x. This is not difficult to show. So the angles x plus y, I've denoted here angle y to be this angle, so I want to keep writing it. This angle is y, this angle is x. X plus y is the angle CMN, which is the same as the angle CKE or CKN, whichever you want. You can write here as CKN. I'll draw here one more circle that's passing through those 4 points. How do we know that this angle CMN is equal to the angle CKN? Because it's the angle on top of the same arc here, you see, is the same arc. So this angle here this angle CKN and CMN are equal, but CMN is twice KAC. Why it's like that? Any idea? Why this angle CKN is twice CAN? All right, if you pay attention, the triangle ACE is a right angle triangle. You can check these ones. Uh, it's a right angle triangle here. AK is equal to KC is equal to KE. Well, if that's the case, then K should be the center of circumscribed circle. So it means that this is the central angle, KCE is the central angle of this big triangle here. And this is the peripheric angle. If this is, let's say, 2 alpha, this should be alpha. So it means that this angle here is 2x. From the equation x plus y is 2x, it means that x is y. And we proved that those two angles are equal. Any question? All right. You just ask for it. No, I picked the problems from somewhere else because, you know, you have the sigmas and I'm pretty sure you already solved those problems. Some of the problems are from this book. Zbierka zadaci po matematyka, also known as the Blue Book. I don't think so, Philip, but all right. I think the next one is easier. All right, let's continue with the other problem. Let D be the intersection of angle bisector of uh, the triangle CAB and the side BC. So basically it's this one. This is point D. Prove that AD squared is AB times AC minus BD times DC. You will have now more than 5 minutes. Let it be 8 or 10. let's give you a hint, it will help you a lot. It's let E be the point where angle bisector intersects the circumscribed circle of ABC. So this will help you, and maybe if you solve it, inform me on the comments. All right, let's show this part, because these two triangles ABE and ADC, I didn't draw here the circle, all right, circumscribed circle. Let's say it's this one. We said continue this line till here and denote this point with E. Because this was the bisection, these two angles are equal. And the angle, this angle is equal to this angle. So these two triangles, triangle ABE and ADC, are similar triangles. Then we have this proportion AE over AC is AB over AD. Just some algebra, we end up with this equation. Here, instead of AE, we wrote AD plus DE, which is the same AE. The other part is this one. These two triangles are also similar. ADC and BDE. Then we have this proportion, AD over BD is DC over DE, which means that AD times DE is DC times BD. And just substitute this one, AD times DE, substitute here, which is DC times BD. And we got the part from the problem here, which was asked to show that AD squared is AB times AC minus BD times DC. So it's here. Let's continue with the other problem. Can we continue? All right. Here is given this circle. I just didn't denote the center, right? Let it be O. Then we have this shape inside the circle. So we have a chord here with length A, then perpendicularly with that another segment. It's not a chord, that one. It's a segment B, and then perpendicularly with that one, another segment C. Express the radius of this circle in terms of A, B, and C. All right, let's continue. This problem is interesting to solve. Let's extend this line here. All right, then we can take another perpendicular line here also. Then what do we have? The length of this line here, let's denote A, B, C, D, those points. And let's extend this one here, E, F. All right, CD is also A because it's perpendicular parallel there. And DG will be C. Why that's C? I'll leave it to you to think about that, but it's not difficult at all. All right, so this side now it's A plus C, this side C, this side C here. This is point C, don't mix it, this is point C. And let's denote this side with small d. We will need something to solve this problem. You maybe heard about power of a point. If you have a circle and a point in the outside of the circle, it may be inside, just not to be on the line itself. Then OA times OB is OC times OD. If you want to copy this one, it's called power of a point, if you don't know it already. YDG is C. Let's take here a line perpendicularly. It bisects. This will be A over 2, this will be A over 2, and it bisects FG. So if this is C, this must be C also. Is that clear? Now there is the power of point for those who... All right, we will apply here the power of the point for point C. Here I can show it to you. We apply the power of point for point C, so B times D from C to B, CB, which is just length B, times CE, which is D. B times D is C times, this side was A plus C, so C times A plus C. All right, I'll show you and more calculations. Now, here we got that D is C times A plus C over B. And where did we got this equation? We just apply the Pythagorean theorem for the triangle ABE, because this triangle is a right angle triangle. We can apply the Pythagorean theorem for this triangle here, and this side is 2R, this side is A, this side is B plus D. So we apply the Pythagorean theorem and we got this equation. Now we need to express here R in terms of A, B, and C. Because it's the center of the circle. Well, we know that every triangle constructed on top of the diameter, it's a right angle triangle, and ABE is a right angle triangle. It's given that AB is perpendicular to BC. Did you copy this one? Well, because look here, it's 2. When you divide it and then take the square root, it will be left square root of 2 here. Oh, sorry, there is my mistake here. Look, it should be like this and like this. Sorry, I forgot it. Thank you very much. All right. From this point on, you can leave it like that, but why not to see something better? A lot of calculations. I mean, just calculation. You don't have to do this from that point. It's done. But here we got something which looks a little bit better than that one. If you want, you can pause the video later, not now, and copy this thing. It's just calculation and factorization. All right, let's continue with the last problem. Great. It was just factorization, nothing, just to make something look better, but yes, O is the center of the outscribed circle. Circumscribed circle or outscribed circle. As I see, Blaja solved it. Congratulations, Blaja. All right, let's see something here. What can we do? Let's first connect AC and BD, which are the diagonals of this quadrilateral. It's given that AOC is 4 times BCA. Let's say this is angle phi. All right. Let's say that this is angle phi. Then if BCA is phi, then BDA is also phi. How do we know that? Because these two triangles have the same arc. They are constructed on top of the same arc. This angle should be 4 phi. If the central angle on top of the arc AC is 4 phi, then the peripheric angle on top of this arc AC will be 2 phi. So this angle, which is ADC, the peripheric angle here will be 2 phi. If ADC is 2 phi, but ADB is phi, then this one must be phi. Let's denote this point here with E. Let's denote this point with E. Then these two triangles DBC and the triangle, here it's written, the triangles DBC and the triangle CBE are similar, not congruent. They are similar triangles. Why those two triangles are similar? Maybe I need to check that one. I have another solution. I think we have just one more line here and done. Maybe that one works. I need to check it later. All right, now this angle, the angle BDC, the angle BDC is equal to the angle BCE. Sorry, 1 second. Yes, this angle B, because these two are similar because they have they share one angle, and the other angle BDC is equal to the angle EBC phi. This one is phi also. Because these two triangles are similar, then you just take the proportion. BC over BE is BD over BC, cross multiply, and we end up that BC squared is BE times BD. Is that clear? We finished earlier today. Let me remind once more for this competition, if you want to participate, here is the link. You can check for any information here, or you can ask me. Registration deadline, as you see, it's 29th of January, so you don't have much time. All right, goodbye, see you, we're done.